Okay, hello. In this video, we need to evaluate the limit as x approaches 3 of f of x. But notice that f of x is a piecewise function. That means it's in pieces. We have two parts. First part is when x is less than or equal to 3, and the second part is when x is greater than 3. So remember, in order for the limit to exist, the limit as x is approaching 3 from the left of your function and the limit as x is approaching 3 from the right of your function must be going to the same function value. So as x is approaching 3 from the left, we can consider all the values to the left of 3, which is less than 3. So we'll be using this top piece. Then, to do the limit as x is approaching 3 from the right, those are all the numbers that are greater than 3. So we'll use this bottom piece. Now, we don't have to use algebra techniques. We can just use direct substitution. So we'll go ahead and plug 3 in for x. So this becomes 1/3 times 3 minus 5, which is -4. This becomes -3 times 3 plus 7, which is -2. So these values are not equal to each other. Therefore, what can we say about the limit as x is approaching 3 of the function period? Well, as we approach 3 from the left, the function value is going towards -4. And as we approach 3 from the right, the function value is going towards -2. So those function values are not going to meet each other. Therefore, the limit as x approaches 3 of the function is dne, does not exist. The best way to see this would be to graph this. So let me pause the video real quick. Okay, so I paused the video just to make my graph. I knew it would take me longer. So let's look at our piecewise function. Look at your graph. So the first piece says x is less than or equal to 3, and that's f of x is 1/3 x minus 5. Well, when x is 3, because there's an equal sign, I have a closed circle. Okay, the second piece says x is greater than 3, and the function is f of x equals -3x plus 7. Notice that this time it's just greater than 3, so I have an open circle. But if you pay attention to x approaching 3, so as we're approaching 3, from the left, the function value is going towards -4. From the right, the function value is going towards -2. These two are not equal to each other. There's a gap here. This is a discontinuity, so it's discontinuous at x equals 3. Therefore, we can understand that the limit as x approaches 3, either from the left or the right, is dne, because from the left or from the right, they do not match up. They do not meet each other. So when given a piecewise function, and they ask you to evaluate the limit as x is approaching a number, no direction given, you must evaluate from the left and from the right. Now, let's say they asked us the limit as x approaches 3 from the right of the function. Well, we will come to our piecewise function, find the piece that indicates that we're approaching 3 from the right, which is the bottom piece. We did that down here, and that answer is -2. Let's say they say the limit as x approaches 3 from the left of your function. Do the same thing. Find the piece of your piecewise function where x is less than 3, because that's what it means to be to the left. We use direct substitution. We did it down here, and we end up with -4. But if they say, hey, what is the limit as x approaches 3 of your function? If these two values are not equal to each other, then this thing is dne, does not exist. So hopefully this has been very helpful. Have a good day.